Hey everyone, welcome to today's video. Today we will discuss a low-level design problem statement. It's called Design a Comments Library, which is similar to Facebook, LinkedIn, Reddit, or any comment feature that you have seen on online, like a blog post or anything. We will be talking about the requirements, the classes that we need, and then we'll proceed with the implementation. Now typically we in an interview we have 30 to 35 minutes, or at max we can have 45 minutes of time to complete this problem. So we'll try to complete this problem in this time only. If I start with the requirements, the very basic requirement is that user should be able to comment on a post. Let us call post on which we have to build that comment library. User should be able to reply to a comment. This is an important one. User should be able to edit or delete a comment. User should be able to retrieve all comments for a post, and also get all replies for a comment. These requirements looks good. There is one thing which we left is that deleting a comment should not delete their replies. These are the requirements that we should scope in, and these should be good to go with. One thing which you can check is with your interviewer that are these requirements sufficient, or does the interviewer is looking for something else. But generally these are enough. The next part that we will move is on the classes and identify what are the classes that we will be needing for this design. The first class is very obvious, is a comment. Actual class holding the comment data. We will come to the exact implementation of classes in a later section. We forgot one requirement, which is user should be able to react to a comment. Basically it's a like or something, and then there is a reaction class to hold the reaction of a user on a comment. Third, we will need a comment library or a comment controller, whatever you can name it. This will be the actual facade of our library that will expose all public functions. Then we will also need since it's a low level design and generally we don't talk about databases much in this design, what we will do, we will create a repository class to store data in memory. All right, so yeah, so these are the four different classes that we'll be using. Now let's start with the implementation. Now in the implementation I'll use the actual code and start with the basic one, the public class comment library. Let me define other classes as well. Class comment. And by the way, I'm just using Java as a language here. The interview does not depend on which language you are using. You can, so it will have the functions create comment, create reply, which will take some comment ID, edit comment, delete a comment. Then we will have get comments and get replies, react on comment, and react on comment. So we will have these functions. I'll define the exact function signature as we go on, but these functions should satisfy our main requirements, like able to comment a post, create a reply, edit, delete, retrieve all comments, get all replies for a comment, and delete is the user should react to a comment. Let me now also structure my comment class. This will be the class which will hold the data related to comment. It will have comment ID, it will have string comment, or let me just write the as message. It will have a post ID. It will also have a user ID who commented on this, or for a bit character naming convention, let's go with author ID, string of parent ID. Now this is interesting part. There are two options. Either we create a nested comments, we create something like a list of comment and replies inside this, or we store a parent ID and create a flat structure. Both are these have their pros and cons, and I'll explain why I went ahead with the flat structure. Because in a nested structure, to figure out to edit or delete any nested comment, let's suppose your comment is n level deep, so you have to traverse the complete n levels and then edit or delete that comment, which will be very inefficient for our edit and delete operations. So going with the flat hierarchy is much more efficient. Also, it will help us in supporting pagination, which we will discuss later. Long as created at, basically it's a timestamp, and a long updated at a boolean is deleted. So this is our comment structure. Now coming on to the reaction part. So it will have a comment ID, it will have string as user ID who reacted to that comment, and something like a reaction type and reaction. So why I'm using this as a enum is because the reaction can be many different types. There is a like, for example in LinkedIn you have like, celebrate, insightful. So we will create a reaction type as enum, and for now we will just support the like one, and then there will be a timestamp field. Coming to our repository class, we will store couple of data in memory. Like for example, there is a comment and comment which is like by ID, like new hash app. Then there is new string comment which is actually a list of comment, which will be basically post to top level. It will store all my top level comments. Then there will be my string comma list of comments, and this will be my parent to reply new hash map. So this one we are storing all the comments here. This is not a comment, this will be a string where we will store only the comment IDs here. And then we will also store string comma list of string post to all. Basically it will be just a flat hierarchy of all the comments for a particular post. So this is an optional one. We will not need this, because if you want to get the comments for all the comments for a post, we can use these two maps for that. But for a faster retrieval, let's use this one. And then we also have to store the reaction. So reaction will be for a particular post, so that's a string, and then reaction is for a particular comment, and then by a particular user, and it will take reaction comment reaction new hash map. And the repository will have as save comment, get comment, it will take comment ID, return type is so comment, then there will be get comment, save comment, get comments, and it will take a post ID, and then get replies, which will take a string of post ID and a parent ID. Now one thing to note is that there can be n number of comments for a particular post or n number of replies for a particular comment, so we need to support pagination. So we will have an offset and a limit to support that. Similarly for this one as well, we will have offset and limit. So we have now our classes. Now we'll just complete all the function signature. So it will be public a comment object, create comment, and it will take as string post ID, string as user ID, and string as message. There is one issue with this kind of parameters. So generally we want to go with the kind of a request class to support this, because in tomorrow there is more parameters, we have to make changes in function signature. But in the interest of time, you can just write these parameters and call it out to the interviewer. Create reply a comment, which will be for a post ID, user ID, or I would rather say author ID, and string parent comment ID, and there is string as message. I'll also change this to author ID. We actually don't need a post ID because we already have a parent comment ID. Then we will take a public comment edit comment, which will take as a comment ID. Of course, there will be author ID, we already know. Then there will be an updated message, and it will also take the author ID in case we have to perform some validations at a database layer. Delete comment, string comment ID, and string author ID. Yes, now get part is interesting. So we will have a list of get comments. It will have string post ID, int offset, and int limit. Get replies, a public list of comment. Get replies, string parent comment ID, int offset, and int limit. And react on a comment, so it will be public reaction, string as comment ID, string as user ID who reacted, and the reaction type. Comment ID, string user ID, and reaction. So yeah, these are the functions that will be supported in our controller classes. So we have the return types and the arguments that we need. Now we'll also complete the function signatures for our repository. So public comment, save comment, take comment as the inputs. Argument, get comment will take comment ID. I'll just make it as null for now. List of comment, get comments, simple, and it will be public list of comment, get replies. Return new array list. We have our repository defined, we have our the library defined, the functions defined, the class is defined. How it will work is create a comment, the request will come, it will call the repository, it will save the comment to post to top level, the post to all, and for the get comment, it will take the comment ID, it just check from the comment map, it will return the get comments. Now this is an interesting part. So there are two cases. Let's talk about those. The first use case is that we have 10 top level comments. Then we have each one will have like a 5 or 2 nested comments, and the further 2 nested comments may have like a 5 replies. So it's kind of like 10 comments on top at level 0. Then you have 5 comments on level 1, and then you have 2 comments on level 2. Right, so you have total of 17 comments for a post. Now whenever the client calls our comment library, it will call get comments, and it will return all the top level comments with the limit and offset. Then the client will call replies for the next set of comments. So it will return the level 1 comments. So this has returned the 10 comments, this return the 5, and further for the 5 comments it will again call and it will return the 2 comments. Now note that here the client has to call 3 times to fetch all the 17 comments, which is not very efficient. Like just for 17 comments the client has to call 3 times, or even for even more number of times. So to prevent that, like basically to optimize that, what we can do, we can keep a threshold. For example, we can keep a private static final Main threshold. Yeah, the logic will be if total comments for a post is less than the threshold, then return all, else return top level only. This is the one using which we will be able to optimize our comments library. The main catch for this problem statement, the comment library, is that we can have a this threshold logic here, and we can expose from the repository public int total comment count, which will take a post id and return post to all dot get post id dot size. Of course, it will check if post to all dot contains key post id, does not contain key, return 0, and this will be referred here. Now the comment library will also have this dependency injection report total comment count post id. If this is less than the threshold, pull all, else repo.get comments. So yeah, this is the main structure of our low level design. Now I have created a Medium blog post for this low level design with the complete code, and you can check that code in the description, check that blog post in the description that I have attached. Feel free to like, comment and subscribe to the channel for more such videos. It will tell me that you are liking this video, and if you want me to create videos on any specific topic, do let me know. I'll be very happy to learn about that topic and create videos on that topic. And also we can discuss, if you have any comments and suggestions for this design, do drop them in the comment section. We'll surely have a look and we can discuss on your suggestions. Thank you and have a nice day.